Welcome to part 5 of lecture 3 series that is focused on build pipeline plugin demo, chaining jobs, running the pipeline, continuous delivery and continuous deployment demo. Up until this point, we have learned how to create individual Jenkins job. However, real-world software development rarely consists of just one task. Think about our food delivery application. Suppose our developer pushes a new code, what happens next? First, the source code is downloaded, then the application is compiled. After compilation, unit tests execute. If they pass, the integration tests begin, and if those succeed, the deployment starts. Finally, notifications are sent to developers. Notice that these are not independent activities. Each one depends on a successful completion of the previous one. If compilation fails, testing should never begin. If testing fails, deployment should never occur. So therefore, we need a mechanism that allows Jenkins to connect multiple jobs together into a logical sequence. This is exactly what the build pipeline plugins provide. Instead of requiring a developer to manually click build now for every stage, Jenkins performs the entire sequence automatically. This automation significantly reduces the manual effort and ensures that every build follows exactly the same process. Now let's configure our first downstream job. We are going to modify the first job we created earlier. This first job is responsible for building the application. From the Jenkins dashboard, locate your first job, click on the job name. Now select configure from the left hand menu. Notice that we are not creating a new job here, instead we are modifying the behavior of an existing job. Scroll down until you reach the post build actions. This section tells the Jenkins what should happen after the current build finishes. So remember our objective. As soon as job 1 completes successfully, we want job 2 to begin automatically. So we are essentially telling the Jenkins, do not stop after building the application. Continue with the next stage. This simple configuration transforms isolated jobs into a connected automation pipeline. Inside the post-build actions, at post-build action, a drop-down menu appears containing several different actions Jenkins can perform after the build. For today's demonstration, select Build Other Projects. This option is exactly what its name suggests. After the current job finishes, Jenkins immediately starts another Jenkins job. Think of it as handing work to the next employee in the assembly line. First employee finishes assembling a product. Instead of leaving it on the table, they immediately pass it to the quality inspection team. Similarly, job 1 automatically hands the control to job 2. After entering the project name, click apply and click save. And at this point, this relationship between job 1 and job 2 has been established. Whenever job 1 succeeds, job 2 starts automatically. So this is our first example of workflow automation inside Jenkins. Now let's visualize this pipeline. Notice how Jenkins presents the connected jobs visually. Instead of displaying isolated projects, Jenkins now shows the flow from one stage to the other. Imagine a company with hundreds of software projects. Without a pipeline view, developers would constantly wonder which stage failed, did testing complete, has the deployment started. So the pipeline view answers these questions immediately. You can observe exactly where the execution currently is. If one stage fails, you will immediately know which part of the process requires attention. So visualization is one of the Jenkins' strongest features because it allows the teams to monitor complex automation workflows at a glance. Now let's execute our pipeline. In the pipeline view, you will notice a small plus icon. So this icon allows us to add an initial job to the pipeline visualization. Click the plus sign. Jenkins now asks which job should act as a starting point of the pipeline. Remember, every pipeline must have a beginning. In our project, on our example, the first job is the build job because software must always be compiled before testing and deployment. So we select the build job as a starting node. From this point onwards, Jenkins already knows what we configured earlier. Once build completes, Jenkins automatically proceeds to deploy. Once the build job begins executing, every downstream job starts in sequence according to the pipeline configuration. Click OK after selecting the initial job, so the pipeline is now fully configured and ready for execution. Now let's see what is downstream job. A downstream job is a job that doesn't start on its own. Instead, it waits until the upstream job has completed successfully. In other words, it depends on the success or output of the previous job. If the upstream job fails, the downstream job is usually not executed because the required conditions have not been met. The downstream job performs the next stage in the CI/CD pipeline. Depending on the project, this could involve running unit tests, packaging the application, performing security scans, or deploying the software. Since it relies on another job to begin execution, it is commonly referred to as child job or dependent job. So this dependency ensures that every stage executes only after the previous stage has been successfully completed, making the automation process more reliable and reducing the unnecessary failures. Jenkins job can both be an upstream and downstream depending on its position in the workflow. Everything is ready. Let's finally run the pipeline. Clicking this button starts the entire automation workflow. Notice something important here. We are not running multiple jobs individually. We are running one pipeline. So Jenkins automatically takes care of everything else. Once the pipeline starts, the build job begins. After build completes successfully, deploy automatically starts. If there were additional downstream jobs, Jenkins would continue executing them one after another. This demonstrates one of the biggest advantages of automation. One action triggers an entire sequence of operations. Instead of repeatedly interacting with Jenkins, developers simply initiate the pipeline and allow the automation to perform the remaining work. So Jenkins uses colors to communicate the build status. These colors allow the developers to understand the pipeline progress without opening the detailed logs. When a stage appears yellow, it means job is currently running. Compilation may still be in progress, test may still be executing, deployment may still be underway. So yellow simply means please wait, Jenkins is still working. When the execution finishes successfully, the state changes to green. So green indicates the success. Compilation completed, maybe test passed, deployment succeeded. So everything worked correctly. You should also know about another color that is red, which indicates failure. Whenever a build turns red, developers immediately investigate the logs to determine what went wrong. So these simple color indicators allow the teams to monitor the hundreds of builds very efficiently. Now we are going to extend the automation pipeline. Our pipeline consists of two jobs. Job 1 performs the build and job 2 performs the deployment. But real-world software delivery often contains additional stages. For example, after deployment to a staging environment, a release manager may manually verify the application before allowing production deployment. So this brings us back to the concepts we discussed earlier, continuous delivery and continuous deployment. So this is the demo of continuous delivery. So in the next few slides, you will see we will create the third Jenkins job. We will demonstrate the job starts automatically. We will achieve continuous deployment. And this is the demo of continuous deployment.